So now let's talk about finding the inverse of a function. So here are some steps that you can follow. So the equation of an inverse of a function f can be found by doing these steps. I start by replacing f of x with y in the equation. If it already says y, then obviously you wouldn't do that. But the reason why I do that is to remember or to remind me that an inverse function switches the x and the y coordinates around. So our first step, and the part that people usually get hung up on and don't know how to proceed, is to flip those x and y's around. So you're going to write the x where the y is and the y where the x is. So you're just going to interchange those places in your equation. Then you're going to solve for y. What that means is you're now doing every opposite operation on there. And so when we finish solving for y, you basically have the inverse function. It's just we want to write it in the proper notation. So you want to replace the y with f and a little tiny -1 superscript. And that's going to note to your reader that that's the inverse of f. We can confirm our result by plugging in some numbers and seeing, oh, if I plug in a number for into f and I get an answer and I plug that into the inverse function, do I get the same thing back? So that's one way to check yourself or to make a composite function, which we actually haven't done in Algebra 2. But you will learn those later on. Okay, you can also visually check. So you could see, oh, do these appear to have the opposite operations in the reverse order? Or another way that you can check is to graph those functions in your calculator and look for that symmetry across the diagonal line y equals x. Let's start with an easier question. So I'm going to be thinking about these guiding questions as I go along. What can I replace f of x with? Oh yeah, that is just y. So I am replacing the f of x with a y. And then I also remember that the major concept of an inverse function is that it switches the x and the y around. So everything's opposite here. So I'm going to write my x where my y is, and I'm going to write my y where my x is. Now I just want to solve for y. So I want to use those inverse or opposite operations. So first thing I'm going to do is add 5 to both sides. That's going to give me x plus 5 equals 7y. And then I'm going to divide by 7 because that's the only other thing that's happening to the y. So divide by 7, and that gives me x plus 5 over 7 equals y. This is actually my inverse function. I'm just going to write it in inverse function notation. So I'm going to write f of x, and then I'm going to put a superscript -1, and that just reads as inverse of f, equals x plus 5 over 7, and that is my final answer. So I just kind of want to think about, does this answer make sense? Does it appear to have the opposite operation? So in the original I had a -5, now I have a plus 5. In the function I had a multiply by 7, here I have a divide by 7. So those things do make sense. I just want to let you know that you may also see something like this written in another form. This could be written 1/7 x plus 5/7. Okay, so that might not look exactly the opposite from what we started with, but technically it's equivalent. And so sometimes there's some different ways of writing functions. It doesn't mean they're wrong, but it's just taking a different form. Let's look at another teacher model. This one's different because it's not linear. We actually have x cubed. And I just wanted to show you one that's a little bit harder. So how do I make the inverse function from this? Well, using my guiding questions, I should replace f of x with y. Okay, and then the major concept of the inverse function is, hey, everything's opposite. So I'm going to switch my x with my y, keeping everything else the same. And once I do that, then I can just solve for y. We solve for y by doing the opposite of whatever's being done to the y. So I'm going to minus 1 from both sides. That results in x minus 1 equals 2y to the third power. Now look at what's being done to the y. It's being multiplied by 2, so I'm going to divide by 2. That gives me x minus 1 over 2 equals y cubed. And we want to think about what's the opposite of a cube. What's the inverse operation of cube? Well, it is a cube root. So just like squares have a square root, cubes have a cube root. So I have cube root of x minus 1 over 2 equals y. This is actually my answer. It's just that I'm going to write it in function notation before I circle it. So that f of x with that little -1 superscript, that is just letting your reader know f inverse. And then I kind of want to visually check it. Yeah, it seems like I have a plus 1, a minus 1, a multiply by 2, a divide by 2, a cube root. So all those opposites should be there in one form or another. Now they might look a little bit different, kind of like that example I just showed you where you can write it slightly differently, but they should appear there. I would suggest that you pause this video and try the WeDo on your own and use the guiding questions if you get stuck. Then play the video when you think you're done to check your answer. So first step I'm going to do is replace f of x with the y. Then I want to think about changing the x and the y around because this is the inverse function. So I'm going to write x where the y is and y where the x is, keeping everything else the same. And then at that point, I can start to solve for y by using inverse operations or opposite operations. So I'm going to subtract 3 from both sides. X and -3 are not like terms, so I can't write those together. And then I have a multiply by 2, so I want to divide by 2. So I get x minus 3 over 2 equals y. So this is actually my answer. It's just that I'm going to use function notation with that superscript -1 to show my reader that that is actually the inverse function. And that is my final answer. And I just want to check it. Seems like we have opposite operations. Now, if we were taking a multiple choice test, though, you might see the answer in a different form. You might see it written like 1/2 x minus 3/2 or something like that, but it should be the same. So I want you to try to work with a partner, whether that be your shoulder partner or someone nearby because nobody's sitting next to you. But go through these together. There's actually 2 you-dos, and I know this is a little bit weird, so I want you working with somebody. So partner A, you ask the guiding questions to partner B as they solve the problem, especially if they get stuck. And partner B, you answer the guiding question and work the paper out on your problem. Then you're going to switch roles and do the second problem there. Here's a look at the first you-do. So one partner doing it, the other one sort of coaching with the guiding question, and then trade places for that second you-do, with one person coaching and the other person actually working it out on their paper.